many things on Sonet. What is Sonet? Then hierarchy of Sonet. Okay. Then different topologies which comes under the LBN Sonet. Sonet networks, which includes point to point, ring network, multi-path network, so many things, right? Also, we have discussed regarding unidirectional path switching and bidirectional path switching of Sonet network. A brief about a synchronous optical network hub model as well. Okay, vertically as well as there will be an horizontally same set of components, right? We are trying to use it to write this model. I think I need to start from this particular slide. Okay, let us continue from here today. The first thing is Sonet layers. Sonet provides 4 layers basically. One is a photonic layer. It is nothing but a physical layer where the rest of the 3 layers, that is section layer, line layer and path layer, lies in data link layer. Okay. When we go ahead with the photonic layer, it corresponds to the physical layer of your OSI model. It includes a specification of the type of optical fiber. It may be used and required for minimum powers and dispersion characteristics of the transmitting lasers and the required sensitivity of the receivers as well. Okay, it is like a physical layer of your OSI model. Coming to the section layer, it is responsible for the movement of signal across a physical section, handling, framing, scrambling, and error controlling capabilities or techniques, you can just say. And also, it is responsible for converts electronic signals into photonic ones. That is the responsibility of the section layer. Moving on to the next layer, that is a line layer, where this layer is responsible for synchronization, multiplexing of a data onto the Sonet frames, which includes protection and maintenance of functions and switching capabilities as well. Okay, that's what is your line layer responsibility. And lastly, we have there is a path layer where this is responsible for the movement of signal from one optical source to the another optical destination. It's like end-to-end transport of a data at the appropriate signaling speed. That is what is the path layer is. If you want to understand more details of it in terms of each layer with a pictorial notation, I think you can easily understand here. See there, the first one comes under the LBN path, that is from source to the destination, right? Whereas line is it is one layer to the another layer of your Sonet network. And section is it is basically creates the basic Sonet frames during your data transmission. Yeah, we have different types of signals as well. We can call these things are hierarchy of electrical signals levels, and you can also call there will be synchronous transport signals. Optical signals are also called there will be optical carriers. I mean, you can use a different terminologies as in when you talk about your data transmission from source into the destination end. Yeah, this is the another view of right Sonet system hierarchy. Okay, as I mentioned, we have the different layers, right? How each layer is represented or indicated during your data transmission from source to the end. You can observe it from this diagram as well, and this is also you can call it as an right logical hierarchy of Sonet architecture, right? Or you can also say there will be an physical hierarchy of Sonet architecture with different terms which are available in case of Sonet technology, which includes right, terminal at both the ends, uh, multiplexer and demultiplexer, regenerators in between, and also add and drop multiplexers where you want to add any right now multiplexer in between to combine the incoming signals into right one channel. Okay, and at the same time you want to drop it any kind of multiplexer in between, you can also do that. Yeah, this is another view, right, where this talks about various right optical cables which you can use it. Probably you can notice from the diagram that right we have OC1, right, OC3, and similarly we have the different versions as well. Okay, not it is OC1, OC2 itself, right? You have the various channels. Right, roughly we have there will be 256 different types of OC cables are available, and all these cables provides different data rates uh, as well. Okay, with different payload in terms of very low end speed to there will be a very high end speed during your end to end communication. We have certain examples to note, right? I'll talk about those things a bit later. Yeah, as you have already observed that there is a regenerator, you can use it during your end-to-end data transmission, right? You should also know about what is a regenerator and what its responsibility is, right? It is needed when due to the long distance between multiplexers, the signal in the fiber becomes too low. Okay, as and when you use more and more regenerators based on your requirement, certainly you can maintain very good stability in your signal strength. Okay, like a repeater concept, you can think about it. And at the same time, right, as I mentioned earlier, that's an add drop multiplexer. You can also observe that how add drop multiplexer is deployed in this particular diagram, where you are trying to receive right signals from the more than one channel. Certainly you can use this, or even you want to right combine all of them to one channel. You can really think about there'll be an add and drop multiplexer. Okay, and these things are very essential as and when the traffic is going to become there'll be more and more. If the traffic signal channels are right limited, then these components may not be essential. Okay, especially in case of there'll be an telecommunication. What you may be using different channels, right, from different regions. Then you to combine all of them together into right, a common transmission medium. Then these things are very essential. Yeah, this is the right, no, deployment of your Sonet with different components, whatever we have understood, right, it's very easy to understand and to go through about a simple Sonet network architecture, right. Starting from the Lillian terminator, you can call the Lillian T there, right. Then we have the ST multiplexer. It is nothing but synchronous transport signal multiplexers, right? No, where the concept of the multiplexer, where it is an N to 1 concept here. Then we have there will be multiple regenerators in between. Responsibility of regenerators now, and we have there will be an ADM. ADM is add drop multiplexer. Okay, you can just add it as your requirement, and certainly you can able to connect these things at the demultiplexer end. It is nothing but synchronous transport signal demultiplexer, right? And further signals are going to be redistributed to different right terminals as per the right requirement. Yeah, then we have two types of architectures. You can use it probably. One is in two fibers, where if you make use of two fibers, it is an unidirectional path switch ring network. You can establish it. If you use two fiber or a four fiber, then you can have the bidirectional line switch ring network in case of the Sonet networks. Yeah, that's the whole idea, is how we can do the a bidirectional and unidirectional Sonet work, right, using there'll be a 2-bus pair, or there'll be an 4-bus pair. I'll just show you those things now. This is the one simple Sonet ring. Since you have already studied the different types of the network topologies, you can easily write Sonet ring network as well. It goes on similar to the same concept, but however, the more important point we have to note it here is, as and when you use the Sonet ring network, what fibers we use it. Okay, don't use the a single fiber. Okay, we need to make use of the a 2 fiber, and 4 fiber bus. And you can also have, there is a unidirectional as well as there'll be a bidirectional. Okay, you can start from there'll be clockwise as well as there'll be an anti-clockwise direction. Even if one node fails here, certainly the data transmission start functioning from in the reverse direction as well. So some kind of reliability is going to become, there'll be more and more when you go ahead with bidirectional data transmission. Yeah, that's what we have. There will be in various terminologies relating to Sonet data transmission, starting from there will be an unidirectional line switching ring, bidirectional line switching ring, then we have unidirectional path switching ring, then bidirectional path switching ring. I think when I'm talking about line switching and path switching, okay, these are all related to the layers of Sonet, what I mentioned during my earlier presentation. Hence, you must understand, what is a path, what is a line, what is a section, then you can easily follow it. What is ULSR, BLSR, UPSR, and BPRSR terminologies. Apart from that, we have, there will be 8 possible ring architectures in case of Sonet. That is, one is 2 fiber unidirectional path switch network, then 2 fiber unidirectional line switch network, and 4 fiber bidirectional path switch network. So rather, I could say that, Sonet network you can design, deploy using unidirectional or bidirectional line and a path switching options. We have very good flexibility to design and deploy your Sonet ring networks. Yeah, this is the another version of the same thing. I think you can easily follow the right uh, diagram and how working happens in case of unidirectional, and there will be a bidirectional Sonet network. Yeah, in case of unidirectional routing, if you look at the first one, right, working channel, that is an B to A in the same direction. It moves on. It moves on from there will be the A to B. It goes on. See, whatever the nodes you connect it, you can just talk about that. On the right hand side, you can see the right bidirectional routing, and you can talk about that bidirectional routing or data transmission happening. See, you can use these things as and when the requirement is right as per the requirements. Otherwise, don't use the bidirectional. Certainly, you can go for the unidirectional routing itself. Yeah, we have certain differences between Sonet and OTN networks. OTN is nothing but optical telecommunication, that is a network, right? Whereas we have, there will be the Sonet. The various its functions, structure, and other things. You can easily talk about. Yeah, what is asynchronous management? Where it's going to become of payload. In case of ODN networks, timing distribution not required. In case of Sonet, requires right timing distribution across networks. Then designed to operate on using, in case of ODN networks, here designed to operate on multiple wavelengths. Scales to 100 gigabits per second, whereas this is 40 gigabits per second, right? And for perform multiplexing. So that's the reason I've already you have synchronous multiplexer and drop multiplexer supports that particular concept. Then OTN networks uses a fixed frame size and increases frame rate to match client rates, whereas it uses there'll be a fixed rate for a given line rate and increases frame size, concatenation of multiple frames for the different clients requirement. Then we have FEC size for error correction to to correct 16 blocks per frame. Here it is not required. In case of your Sonet technology. Yeah, these are all the different speed, transmission speed. Your optical cable provides as and when you use the different cables. OC1, it is the speed is 51.84 megabits per second. OC3, 155 megabits per second. Similarly, the list goes on, right? As I mentioned, you have there been up to 256, right? OC256, it provides you 13,271 megabits per second. So, as and when you want, there will be a higher speed of data rate. Certainly, you have to choose your cables accordingly. And with respect to that, obviously, the cost is also going to be increased, in a linear fashion. Yeah, again, as I mentioned in the previous channel, we have a OC1 bits rate is 51.84 Mbps, and your DS0 channel is 672. DS0 is nothing but a digital signal 0. Even DS0, DS1, DS2 all comes under the OC1 cable itself. Okay, that is 672. Similarly, you have there will be a few other channels Sonet specifications are available here. Okay, it may not be possible to remember, right, all these right, uh, channel data transfer rate and Sonet specifications. At least you can mention right, few of the right Sonet specifications along with there will be data bit rates. Yeah, this is the right, typical OTN network, right, relating to your Sonet technology. Just observe it at the core level. We have there in OTN right switches. Okay, and as and when we moved at the right, distribution level, we have there been two types of routers here. One we call there will be a P router, the another one is an PE router. Right, I think you can easily observe it. Okay, here there's a P router, and the other side we have there will be PE router. PE router is service provider edge routers. These things, right? Where P router consists of number of service providers edge routers. Okay, I think from this particular OTN network, right? If you observe all around this particular network model, right? P routers are connected to a P router, right? At the bottom, top, as well as the left hand side as well. And coming to the P router, all the time, it's a right. This particular router is connected to there will be an OTL core, switching network, right? So the functionality of this right, P router is it will ensures that right how the services are going to be right, provided to the user by doing their necessary configurations right during the network operations. Yeah, this is another application relating to Sonet network. I think since we are talking about nowadays more and more on the metro networking, in order to provide the right higher speed, then more reliability, and even you want to increase the channel speed whenever you want it. Certainly, you can able to achieve using add in multiplexer components. That's what you can observe it from this particular diagram. So since it is connected in a ring fashion, right, certainly in order to generate the signal strength, or you to right have there will be the stability, you can have right, generators and add in multiplexers. As well, you can scale up this particular network with different right Sonet networks as Sonet networks itself, right? You can observe it. There is one scale up right Sonet network, right? This is the second one, third one. Even you can extend this to as many, right? And any kind of services which you want to do it right, you can easily do the things with the help of your Sonet networking. Yeah, you can also call right, synchronous right signal one as there'll be an OC1 again. Then OC3 has there'll be an STS3, in the sense that optical cable you can right also identified with its equivalent Sonet signal and its equivalent SDH signal. Those things are specified from this particular slide. Okay, you can observe Sonet cabling specifications are available on the left hand side column here, and the SDH signal specifications are available on the right hand side. More or less, right, the speed remains same, but the only specifications, the specifications are slightly changing with respect to that. Yeah, this is the another right, application to talk about how universities can utilize optical networking and Sonet networking concept in the campus. Right, I think the whole idea is that as and when you want to do more reliable right end-to-end communication, as I said, right, where it provides, there'll be a path layer communication where the path is source to there'll be the destination without having right, wide area network within a campus. Certainly you can look for it, and you can deploy your routers, switches, right, and that is a different types of local area, high speed local area networks as per the requirement, in the sense that you can have it in case of right, different departments, or even you can have it in the research wing. You can have it right wide, and there'll be in wireless networks as well. Okay, so it depends upon ultimately how effectively and optimizing your network resources are very essential, and also you have to be look for to reduce the overall cost of your network resources without compromising the quality of service which you are providing to the all stakeholders of this particular network, right? I mean, this is one simple scenario. You can write any kind of diagram, but it should be meaningful while writing it, and what kind of resources you're going to use it is left to you. Yeah, this is the right connectivity of your right cables to the right OTN switches at the back end view from the rack side. Yeah, I mean, Cisco also uses predominantly, right, Sonet and SDH network for its own applications and services, right? I've downloaded this particular slide to to illustrate, right, how Cisco uses the LBN Sonet network, right? I think you can observe it from the left-hand side, where we have the LBN service provider, functionalities, and we have the LBN metro access functionality, and on the right-hand side we have again enterprise campus, capabilities. So then we have, there is an inter-office facility of network, right? If you observe all these kinds of networks, we have, there will be an right, one is using, there will be an Sonet topology, the another one is Sonet technology, the another one is using, there will be an right DWDM technology, right, the another one maybe using, there will be an Ethernet technology, like that. So ultimately the understanding here is that we have, there will be an n number of technologies currently available to design and to right now develop your own high speed local area network as per your requirement. That is what is the bottom line. As well, there will be an thumb rule of your networking design approaches, and you can look for at the top of this, right, wherein you can observe there'll be in all kinds of, there'll be in technologies starting from, there'll be in Ethernet, Sonet, TDM, IP, okay, or it may be right, your what do you say, there'll be an optical fiber cabling network, ATM network, okay. It all depends on right your requirement. Yeah, this is the another right scenario, how right, wireless network technology could also be used in case of right, in case of, there'll be Sonet network usage as well. So probably if you see on the right hand side, we have, there'll be so many applications, right, starting from, there'll be in GSM applications, or you're connecting to the network, home service applications, or maybe you may be connecting to wide area network using, there'll be frame relay, or you may be connecting to right now public switch telephone network using your signaling system, right, a protocol that is an SS7, right, and also you can use, there'll be a message level, right, protocols with the help of right, SS7 in case of there'll be an ISDN services as well. So you can have numerous applications, right, with the help of wire technology, or there'll be an a wireless technology, and you can able to communicate with the other end with the help of your Sonet right network. That's what you can observe it, right. On the left hand side we have, there'll be an OC3 cabling, or it is an equivalent to, there'll be an STM bar 1, or even you want to use any other speed, you can use it. You, if you want to add any other things, right now as per your requirement in between, yes, you can add it, you can scale up your network. So but you should have, there will be a good flexibility, right, with your design to add such things. If not, it will be very difficult. Yeah, this is the another right, scenario to talk about, right, optical solutions using, there'll be in Sonet and there'll be in SDH. We can have, there'll be in a n number of nodes, right. We have, there'll be in node A, node B, or even you assume that it is one what do you call, there'll be in a data center where one data center may be connected to right, a n number of networks which are deployed in a campus. Okay, like that you can have, there will be an n number of data centers. All of them you can connect it to the core data centers where you can store the entire data which is coming in from the different regions of different networks, right, ultimately available in a storage server. Okay, you can make use of, there'll be in data centers, make use of, there'll be in storage networks, right. Then all of them are well connected with Sonet, as well as right, other technologies which are currently available to communicate and to do proper kind of, there'll be services relating to your internet. I think these are also the things which you need to be study relating to, there'll be in Sonet and SDH, right. I think I have added, there'll be many more things on Sonet and SDH. You can write your own diagrams as well, but you can also have an idea, right, how really you can construct some of the networks using, there'll be in Sonet networks. Yeah, do you have any questions? You can ask me right now. Hello. Yeah, do you have any questions?
No, sir.
No, sir.
No, sir.
Oh. Yeah. I mean, up to this stage, right, you need to study for your second test, right, which talks about, right, unit 2. And I have, right, some more points to share on SS7 emulator and, right, ISDN emulator, right. I'm going to talk about those two things now. I think I have given a deadline to all of you to complete your right assignment, that is on 30th 09 2020, but I have not received from anyone. Why? Hello. I have given two questions to all of you to write your answers and submit on right, but I have not received from anyone. Why? Tejaswini?
Sir, we will submit, sir.
When you will submit? Sneha?
Yes, sir.
You are there, but why you are not submitting it?
Sir,
Hello?
hello, sir.
Why you are not submitting it? Anybody tried? Tried so far? Hello? Gautarani?
Yes, sir.
Have you tried? Priya?
Not yet, sir. I'll try. I'll try to submit.
What about Priya?
No, sir.
What's the reason?
Sir, we'll do it soon, sir.
We'll do it soon. So you have to stick on to your deadlines, whatever we give some work to you, and you have to complete it, no? And if you postpone your work till the end of the semester, right now, that's not good. I've already mentioned that I'm going to evaluate it each assignment periodically, not at the end. Accordingly, right now, I'm going to allocate the marks to each one of you. Yeah,
I'll submit, sir.
you have to do it soon. Okay.
Okay, sir.
Yeah,
Okay,
fine.
sir.
I'll stop sharing this. I'll switch on to the next, right part from the unit 2. Just a minute. I'll close this, PPT. Yeah, are you able to see my slide?
Yes, sir.
Yeah. I'm trying to talk about now, ISDN emulator. Uh, okay, first and foremost, you have to understand that what is an emulator is basically. In emulator is a hardware or a software that enables one computer system to behave like another computer system. Okay, because nowadays, most of the time we utilize there is an emulator to do so many things. Okay, typically, it enables the host system to run software or use peripheral devices designed for the guest system. That is what is the basic functionality of emulator as well. Say, for example, this is one typical scenario where you can just think about the function of there is an emulator here. I'm expecting an answer from you. What you could able to understand from this particular slide? Anyone of you, please. Hello. Hello. Yes.
Sir,
Yeah. What you can understand from this particular slide? What is your views on this slide? Hello. None of you are able to answer it? Yeah, Veena? Hello?
So once again, you put that slide, sir. It is not correctly visible.
Yeah. I'm talking about an emulator concept now, right now.
Yes, sir.
Yeah, you can, what is our understanding from this particular slide? Hello? It's an Android emulator where, number of apps you can use it in your system to do several functions basically, correct? Where we are trying to talk about how various functionalities you can use it with the help of there'll be an Android emulator. Yeah, let us understand right, ISDN protocol emulator basically, that is an right, we have global communication corporation where they have right, ISDN emulator. It offers a complete solution for testing, troubleshooting, installation, and maintenance of devices and networks implementing. You can call that as an PRI ISDN. I mean, it is an end-to-end right. Validation and checking options are available in this particular, protocol emulator. It is useful to test ISDN product designed for either U or S, T interface, including network terminations, type 1 terminating equipment, and terminal adapters. I think we have already understood that the different types of interface links we use in case of ISDN networks, that is U, S, T interfaces, along with network equipment, terminal equipment, and many more. Correct. All these things you can validate it using this particular protocol emulator. Yeah, your ISDN equipment includes telephones, switchboards, private box exchanges, PC cards, video conferencing equipment, interconnect systems, switches, and there will be routers. Yeah, this ISDN emulator for T1 even network is available as GUI based, as well as there will be command line based applications through which the various ISDN configuration can easily be created, thereby allowing the ISDN emulator to be fully functional within a few minutes. That's what, let us say we have certain options which are available in it, but will it be possible to modify these options? You have to be look for it when you take up some work at industries level, because even everyone may be using one or the another emulator to describe and to validate the same thing, but sometimes the functionalities may be right, limited. Then you need to add up those things. That is where your contributions are required during your internship, and there will be a major project work provided. Sometimes the tool which is already available, you're using it, but how you can add up those things, you can look for it. Yeah, ISDN emulator also incorporates the flexibility to modify ISDN call parameters and message content. Yeah, this flexibility ensures that the ISDN emulator will communicate with the system under test. It is even possible to emulate a complete ISDN connection all in the same PC with a dual interface, a card. I mean, you can easily understand your ISDN protocol emulator functionalities. This is the typical, PRI, that's a protocol analyzer, ISDN protocol emulator. You can observe it. You have there been so many ISDN terminals which are connected to your ISDN PBX, private box exchange switch. Okay. And we have, right, ISDN core switch on the other side, right. You can configure your switches at the prompt, or even you can do the same thing using the GUI based kind of emulator which is available for you. Of course, this is not possible to download it. I tried it to download. Actually, it is in licensed versions. It is not possible to download it, right? But you can have right lot of resources relating to this. But if at all you want to know more and more details, you have to check it from the LBN third party sources. Will it be possible or not? Okay. Yeah. Then just see here. When we go ahead with this, right? Your ISDN provides LBN so many standards and variants. You know that, right? For T1 analyzers include AT&T, that is 4E ESS. That is what is right. We use it in case of the LBN switch configurations of your ISDN, and we have another switch that is an right AT&T 5 ESS, right? Belcore, that is an 5 ESS. National ISDN, 2, and we have, there will be an DMS 250, Siemens CW. I mean, there are so many versions. You can use it as and when you are working with your ISDN, right? Standards. Some of the standards are mentioned here, okay, and you have to be followed right as per the guidelines of those things. Then 1 to 4 configurable signaling links. Supporting protocol layers is, there will be an LAPD, right? This is link access protocol, right? And Q.931 layers, and it also uses the LBN switch and subscriber emulation technique. Yeah, and the other features of this particular protocol is quick configuration is possible for card and calling number. It provides various release cost codes such as rejected, no user response, user busy, congested, and so on. Troubleshoot the problems in case there will be an ISDN. That's what I said. You can just add up, or if you observe that this is not required, you can remove it. There's no hardened rule that you can have all the things. Okay, these are all some things which are currently available. Simple, right? NFSA setup for the LBN T1 link, and we have single dual T1. Okay, dual even interfaces for the ISDN signaling links as well. And we have user-friendly GUI for configuring the ISDN layer parameters, which includes configuring of calling number, plain type of ISDN service, right? ISDN parameters, and many more configurations as well. Yeah, in addition to that, we have call records for complete or incomplete calls, companion product, ISDN protocol analyzers. Okay, it's going to be displayed in all ISDN messages in a real-time environment. Place call or accept call for each time slot or for the whole trunk, communication. It supports overall digit sending details. It exports call records to a text in a text file. Displays lab D, that's in layer 2 statistics as well. I mean, these are all some of the things, right? Where this particular protocol analyzer is going to provide you. Yeah, this is the GUI based right ISDN emulator, right? You can observe it. Okay, if you look at right this particular GUI, wherein we have right ISDN setup, which includes there'll be an start and stop time clock. Then there'll be the protocol. There'll be a variant. That's what I said already. There'll be many standards, right? And specifications. You can utilize those protocols and specifications to configure it. Let us say from the second column, you can observe that there'll be an USA, right? Where if you go back, right, from my previous slide, let us say we have from Britain, France, Europe, Germany, Sweden, Belgium, USA, something like that. Okay, you can just pick up the protocols from that particular region, right? And we have, there'll be the variant as well. As I mentioned earlier, also a variant is 4ESS, 5ESS, all those things. You can write these variants here. Then protocol end. The protocol end is it a subscriber end, switch end, right? Or if there is any other things, you can easily write select those options, and you can select the option whether it is a link down, link up, L1 active. Then you can able to access the right kind of information according to your GUI based inputs. Yeah, extending to the GUI based ISDN emulator. Okay, this is the another GUI based parameter configurations, wherein we have there been time slot grouping. Okay, starting time and there will be the ending time for your applications, because you can also set there will be different types of grouping based on your services, because if the latency is more, right, you then some kind of priority assignment is very essential in case of a time slot time slots. Let us say you have an options like add, edit, delete, or you can save this work as well. Okay, that is possible. And then on the other side, we have there will be a call number, right? We have there will be various options here: a call numbering plan, a call number type, a calling number. Okay, calling number plan, calling number type, calling number screening, calling number presentations. So many things, right? You can just write all these things. I mean, you can set it from the available list. Okay, ISDN service, is it a voice? Because all kind of multimedia applications you can provide it using, there'll be an ISDN service, and you have selected there'll be a voice service over here. Okay, so then you have there'll be miscellaneous right options as well, whether you have a channel indication, user of user information, lower layer compatibility, higher layer compatibility, network specific facilities, and so on. That's what, let us say, when you are right working on projects, you have to look for the GUI application, I mean GUI services. What kind of parameters currently this particular service is providing for the end user, right? So will it be possible to change that? Okay, or can I add one more parameter? If I add that parameter, what is going to happen to my service? Or right, by adding that service, will be able to generate additional reports according to the customer requirement. Those things you need to think about it. That's where you can add up real contribution right during your internship, and there'll be a project works. Apart from there'll be the existing things. Yeah, this is another GUI based ISDN emulator view, where to understand the time slot, call number, calling number, last you can also have there'll be the status of there'll be the calls, and we have there'll be the release cause as well, right? That's what you can just add according to your requirement, and you can make this particular GI is going to become more appealing and service oriented based applications. Yeah, this one more GUI configuration relating to there'll be in COD and there'll be in calling number configurations. Okay, you can observe it. We have a time slot on the left hand side and call number, calling number. Then we have there'll be in calling sub address, a called sub address. See, you have most of the details, what you are expecting during your interactions or transactions, correct? So then generating any kind of report becomes very easy. That's what even you do your online kind of a transactions whenever you want to do some payments, right? So all the details are going to be printed as and when you complete your transaction. That is possible because the moment you do any transactions, the entire data of yours goes and sits at the back end, where as per the details, right, you're going to get, there'll be the report based on the GUI applications. Yeah, this is another right point which you're supposed to note on. There'll be an ISDN. So we talked about there'll be an ISDN subaddress where the ISDN subaddress can be used to address each device when more than one ISDN devices are using same ISDN line. The subaddress is a sequence of digits, the maximum length of which shall be there'll be in 20 octets, right? So you can't use like your IPv4 and IPv6 here. Okay, you have, there'll be a very limited number of, there'll be octets, right, during your addressing as well. Then calling a party subaddress, the purpose of the calling party subaddress information element is to identify a subaddress associated with the origin of a call. Then we have a called party subaddress, where the purpose of a called party subaddress information element is to identify the subaddress of the called party of the call. Okay, so that means we are right summarizing the different addresses which we are looking for, right, in our transaction or services. That's it. You call, whether it's a calling party address or there'll be a called party address, or maybe sub address, whatever it's so. Okay, even you want to identify something according to your need, you add it, nothing to worry about it. These are also the quick configurations relating to your ISDN configurations. Let us say you have, there will be a card one, then you want to select some of the things relating to that particular card one. You can just set those things, card number, calling number, base value, right, base value again. So then you have, there'll be the number of options here. You can have, there'll be the 100, or there'll be 1000, or even you can have, there'll be a less value also. It all depends upon what kind of options are available for you. Then you have an increment value, right, 10 to 100. It goes in terms of, there'll be 100, or there'll be other values as well. Then do the right required configurations and go ahead with that. Once you complete that, so then you get all the details in terms of the report like this. This is what is the generated report examples. Look at this. Suppose call number has to be configured from typically 55001002 to this number, and calling number from this to this using E1 card 1. If there is any changes, in the sense that if you have configured your values, then those values are going to be reflected over here. Then select card 1, you get right, card number details, base value, whatever you have set, increment value, calling number, base value, and there will be the increment value. Okay, so the entire details, whatever you have entered right earlier, those things are going to be reflected. So this is what is the reported examples, what you get it from. There will be an ISDN emulator. We also have, there will be a grouping in case of ISDN. I mentioned about that. That is what is to be called as NFAS. It is nothing but non-facility associated signaling, right? We have, there will be a number of options are available in case of, there will be an NFAS. Okay, this NFAS signals are related to different channels of, there will be an ISDN. I think you have come across of, right, different channels of ISDN, which starts from, there will be an right, B, D, and there will be an H channel. Okay, one is right primary, the another one is a basic, and the last one is going to become, there will be the combination of, right, basic, and there will be a preliminary channels. Okay, where you can have, there will be different combinations in each ISDN channels. Yeah, standard T1 ISDN PRI consists of, there will be 24 channels, right, where a single signaling channel is D channel, that is channel of, there will be 24, controls the remaining 23 barrel channels. Okay, that is the B channels on the trunk in which it is residing. So ultimately, right, you have to understand that what are the different combinations are available when you use, there will be an ISDN services with respect to digital pipes. NFAS grouping allows a number of trunks to be classified into groups, with each group having a unique and identifiable the resultant channel. Then each NFSA group can consist of a trunk containing a primary D channel, and up to there will be 19 additional trunks. Okay, I think you have understood, right, the combination of these channels during my earlier presentations. Yeah, ultimately, right, you can observe, NFS group configurations, right? Just see in the first one, right, with grouping, that's and without grouping at the top, you have there will be in channel 0, channel 1, channel 2, there will be in channel 23. Similarly, you may have there will be in trunk 2, where we have another 23 channels. It goes on, right, you can have there will be an n number of trunks, right, here we have there will be 20 trunk groups relating to without grouping. Similarly, for with grouping, we have there will be an some more trunks starting from there will be an trunk 1 to there will be in trunk 20 here, okay, and trunk 1 and trunk 2 you can pair it as there will be in group 1. Similarly, group 2. It goes on, right, for the available number of groups as well. So what I mean here is, right, when you are providing your ISDN services, specially distributed services, you can provide with two ways. One is, control, your services with user control. Okay, and some services are not available under user control. That's where we are trying to talk about without grouping and with grouping right now. So based on that, we are trying to categorize your NFS group configurations in case of ISDN services. Yeah, there will be a lot of right now technical details as well in case of your NFS group configurations. What I mean is, right, when you started working on ISDN's distributed services with and without grouping, right, so based on the services, you have to choose your right, interface links. Say talk about right your T-Link, or talk about your terminal equipment, network equipment, all those things, right? Unless until you are not using these elements and interface links to design and establish your ISDN network, it may not be possible to have these kinds of groups. Okay, that also you have to keep it in your mind, and you have to work accordingly. Okay. I think this is very, very important, right? How you are going to design and deploy your ISDN networks as well. I'm just trying to showcase it. Just a minute, 1 minute. I'll just open the another slide which is relating to that probably. Are you able to see this? Hello?
Yes, sir.
Yeah, just I'm trying to relate that now. See, this is where I'm trying to talk about it. Yeah, this is what is the ISDN components: network termination type 1, network termination type 2. Right now, then these are all some of the interface links what we used in ISDN. Yeah, this is the ISDN network, right? I'm trying to relate all grouping functionalities with respect to this particular network. You understand, right? You may be doing different services, but these services are related to these components, and you can also establish or provide services with the help of different approaches, starting from switch network, packet network, or maybe in private line network. It depends on you. right? It need not be all the three you are supposed to use it, right? Yeah, this is where I'll just close it, this particular part. Yes. Yeah, that's what I'm trying to convey here. Okay, where T1 comes and your different links comes maybe, and different channels also are going to be used. That a network ISDN network service architecture or diagram you are supposed to be referring. Yeah, then we have certain right standards in case of ISDN specifications. We can call that as an SDN standards compliance. Okay, relating to different countries as well, right? So maybe USA ISDN compliance standards are available. That may be an AT&T, Belcore. AT&T, Belcore. These are all research labs basically. National ISDN 2, Nortel, DMS 250, Siemens, EWSD, right? So many standards are available, right, relating to ISDN, referring to that particular country. You can just Google it and observe it. It may not be possible to know all the things, because these things are very essential as and when you are working to a specific company and its project. Okay, but you must have an awareness regarding that. That is, you have there been different specifications. You have to use it. You have to configure it like that. That's what is the requirement is for you. Similarly, we have an Euro ISDN. Okay, we have certain compliancy from different regions again. Belgium, China, Europe, France, Britain, Germany, Sweden, and so on. Right. Then Asia ISDN compliances starting from, there'll be in Australia, Hong Kong, Japan, Singapore, and right now many more other countries. Okay, you can Google it and you can definitely see in all these things, right? They use signaling protocol, which comes right in case of there is an ISDN, that is an LAPD, right? The another one is 2.931. That's what I mentioned earlier also when I was talking about the protocol stack of ISDN and protocol stack of your ISP model. Okay, where at the link layer we always think about LAPD and Q.931 protocol, right? For data accessibility, or maybe functioning, then synchronization, converting, right? All these functionalities you could able to achieve it using these protocols. And maximum links you can use it right in all the cases is that bin 1 to 4. Minimum is that bin 1 and maximum is 4 links. And we have certain resources relating to the bin ISDN, right? We have XX105. It is nothing but ISDN emulator. It uses either there'll be an T1 link or there'll be an even link. Okay, when I'm talking about T1 or even, it is some kind of you can have there'll be different kinds of input channel into it. Okay, then you can also use a number of software related to ISDN. You can work on using command line interpreter, right? Or even you can use it using GUI based applications. Okay, I think some of you can try by downloading these things, but be careful while downloading. Some of the softwares are you need to pay for it. Okay, ensure that are you ready to pay it? In case if it is required, you can download it. Otherwise, you need not download it, and you can have some understanding about these softwares by reading the contents which are available in the Google websites. Okay, starting from there'll be an ISDN emulator. That's one thing, and ISDN analysis software. and we have there'll be an SDLC capture and pay back software, and we have there'll be an frame relay analysis software as well. I mean, these are all some of the related softwares which are available. And similarly, we have a related hardware, right? That is, one is PTE001 with it is talks about, right, dual T1 even laptop analyzer with basic analyzer software, right? Then we have another one, legacy HDD T1 or even cards with basic analyzer software. Then we have universal T1 even card with basic analyzer software, right? And lastly, we have there'll be portable USB based dual T1 or even laptop analyzer with basic analyzer software tools. I mean, what I mean here is, right, whenever you are working with these kinds of applications, right now, certainly use these resources to acquire there'll be more knowledge and to build your, functionalities, right, according to the requirement. Then we have right now TDM, right, packet and wireless protocol, right, emulators as well. I mean, all these right now tools or protocol emulators details are available from this particular slide. Okay, which right talks about one is in time division multiplexing, the another one is in packet and frame protocol emulators, or it may be ATM technology, or there'll be a virus protocol emulators are also available. So the whole idea is, you name anything you have presently, right, emulators are available to work on and to know the functionalities, or you can learn initially and start working later, right, with other aspects of it. Okay, so that is what is you're supposed to right now understand relating to your ISDN networks. I'll just go to the next slide. Any questions from your end? You can ask me. Hello?
No, sir.
Do you have any questions? I'm going to talk about the another part of right, emulator. Right, just a minute. I'll close this slide, right, just a minute. Hello, in the class ಅಲ್ಲಿ ಇದೀನಿ ಸರ್, ಮಾಡ್ತೀನಿ ಆಮೇಲೆ. ಕ್ಲಾಸ್ ಅಲ್ಲಿ ಇದೀನಿ, ಮಾಡ್ತೀನಿ ಸರ್. Hello.
Hello, sir.
Are you able to see the slide?
Yes, sir.
Yes, sir.
Yeah. Start. Yeah, similar to your ISDN, right, emulator, we have one more right tool relating to your SS7, that is an SS7 protocol analyzer. Again, I've tried to download this. Again, the same problem is, we have to ensure and we have to give, there'll be a lot of details to this. It may not be possible, okay, but you can also understand this analyzer tool theoretically, and right, wherever it is possible to validate at the industry side, you can do that. Okay, I'm trying to provide some more details regarding this particular analyzer as well. Yeah, I think we've already understood what does SS7 is. It's a signaling system, right? 7 separates the information required to set up and manage a telephone calls in the public switch telephone network onto a separate packet switched network. Okay. It uses message signaling units, MSUs, link state signal units, LSSUs, and fill-in signal units, FISUs, as a signal units. I mean, even though we have moved on to many advanced technologies, still, we are using public switch telephone networks predominantly. Hence, the usage and understanding of SS7 is very much needed. And also, right, you can do a lot of things because you can have a right, a separate signaling network, as in when you use, there will be an SS7. The main protocols we use right here is one is MTP, message transfer part, right, that is on level 1, 2, there will be in 3. And we have an SSCP, that is a signaling connection control part, and we have an ISUP, ISDN user part. I think I was already shared, these protocols as in when I was explaining SS7, protocol stack. But again, you need to remember these protocols, right, relating to SS7. Yeah, introducing new ISN services, there is a demand for increasing SS7 network capacity, because the services what we are getting today, right, are varying, right, hence we have, there will be an more and more focus on, there will be an SS7. SS7 is an high-speed link defined to meet this requirement, which uses entire T1 or even bandwidth instead of just 46 kilobits per second or 64 kilobits per second to carry SS7 signaling. This technology can be implemented either using unchannelized SDLC, right? That's an over MTP2. ATM layers replaced with MTP1 and 2 or SIGTRON, because industry most of the time they also use, there'll be an protocol, there's a technology called as, there'll be in SIGTRON. Okay. Traditional LSL links will have up to, there'll be 24 or 31 links per channel, that is in T1 or even respectively, while HSL and ATM both have only one link per T1 or even. We are trying to talk about how high-speed link and low-speed link varies with one another, relating to your SS7 protocol analyzer and corresponding technologies. Yeah, this is the protocol stack, and the complete SS7 protocol analyzer network model. You can observe it, okay, from this diagram. Right on the right hand side, we have, there'll be an message transport level protocols, level 1, 2, 3. Then we have, there'll be an SSCP, TCAP protocols, and at the application layer, the protocols we have just mentioned, that INAP, MAP, SUP, and there'll be TUP protocols. And using SS7 signaling switches, starting from, there'll be an SCCP, STP, right? We have connected to the end service applications, including, there'll be an PBX, modem, fax, and there'll be an analog phone applications. Your SS7 analyzer supports decoding different SS7 layers like MTP, MTP2, MTP3, ISUP, TUP. That's what I mentioned already. Okay. I mean, all these applications you can able to analyze using your SS7 protocol, because most of the time, as in when you want to work with the different services, they will ask you to analyze these things using these protocols. So then you must have right, awareness about the different protocols which we use under the category of there'll be an SS7. The SS7 analyzer supports decoding of both low speed links of 56 kilobits per second or 64 kilobit per second DSO links or high speed 1.54 Mbps or 2 Mbps unchannelized even or even high speed signaling links. Okay. Then your SS7 analyzer collects physical and line level status and performance information, which includes voice, data, protocol statistics, and transmit information to a central distributed network management system. Because we are talking about more on, right, analyzing of various resources which we use it, right? No, certainly we are trying to reiterate that the central or distributed network management system analysis is also possible with the help of this. These probes now supports packet data analyzer with recording capabilities. Packet data analysis is an outstanding tool for living monitoring of signaling and traffic over TDM. It allowing users to monitor the live TDM networks, including capturing, analysis, and reporting of every call in detail. That's what I said already, right? Name anything, it is possible to do it using your SS7 signaling protocol. But the only thing is whether we have that kind of functionality or not, we have to look into it. If it is there, certainly you can do that. Yeah, then we have certain examples with relating to SS7 protocol analyzer. One we call the net survey or WebTM. You can also identify this particular thing as PKV170. It's a central system comprised of a database engine and a web server monitoring system. It facilitates real-time analysis, historical storage, retrieval, querying, and displaying of call detail records by non-intrusively connecting to TDM. There's some time division multiplexing, optical, or there'll be an IP networks. I mean, this is one of the tool which is available. You can use it to do all these functionalities. It also offers a cost-effective, simple plug-and-play connection, which is an integrated and simplified web-based system that is distributed at probe level. So, I mean, what exactly your WebTM or net survey, protocol analyzer is providing to you during the usage of these tools? Such details are available in this particular slide. Yeah, we have certain layers here. Okay, talks about real-time and offline analysis present information in 4 layers, which includes raw SDLC frame data as hexadecimal and ASCII acted dump. Then we have MTP2 and MTP3 information in it. We have a number of protocols which we have mentioned earlier. These things are available. Then apart from that, all the SS7 layers, including application level protocols too. There will be an physical layer details are highlighted, and you can analyze those things as well. And apart from that, we have one more analyzer that is from the GL Communications. Okay, it also supports following types of SS7 analyzers, real-time SS7 analyzers, which includes real-time SS7 analyzers with so many details. Then we have one more analyzer from the GL communication system, that remote or offline SS7 analyzers. Then we have Citron protocol analyzers are available. Then we have scripted SS7 emulsion using there'll be a maps that is in TM. And also we have, there will be an SS7 emulation using MAPS TM central officing switching simulators is available. I mean, what I'm trying to convey is that you have, there will be so many protocol analyzers which are available for SS7 functioning and its operations, and these are all well supported and designed by the GL Communications. Yeah, this is the one simple of such kind, right? I was talking about earlier also, that is MAPS TM SS7 protocol emulator. I think you can observe this particular thing, right? So since you already understood SS7 right now components and other communications from end to end, you can understand that, right? How MAPS TM SS7 protocol emulators are well connected with the other kind of networks with the help of what do you call, there'll be an your message protocols, or there'll be an application level protocols, right, to communicate with the other networks, starting from what do you call, there is an telephone networks to ISDN networks, or there is an ATM networks, or even you can connect it to, there'll be an wireless networks also. Okay. Yeah, then having said this, MAPS TM SS7 protocol emulator, right? We have more details on this particular emulator, which talks about message automation and protocol simulation, designed for SS7 simulation or TDM, can simulate service switching point. The ISUP, that is an ISDN service user protocol signaling specification, conforms to ITUT and ANSI standards. I mean, so many standards and compliancy specifications are available relating to your ISDN, SS7, right, ATM, right, after, Ethernet, fiber optics, technologies. Okay. You please go through more and more details, or it may not be possible to remember all of them, but at least few of them you need to be remember and talk about it in detail. Then the tester supports testing network elements, error tracking, regression testing, conformance testing, load testing, call generation, and generation of high volumes of ISUP traffic. Then MAPS TM SS7 functionality covers the ITU and ANSI variant of SS7, implementing MTP2, MTP3, and ISUP protocols. It is able to run predefined test scenarios against ISUP test objects in a controlled and deterministic manner. Okay, I mean, we are trying to say that what are the different functionality where you are message automation protocol simulation, that is MAPS TM provides you during your SS7 working operations. Yeah, there are many applications are available relating to this, one is we identified it as an MAPS TM SS7 emulator with item XX649. Similarly, we have MAPS TM SS7 conformance scripts item XX647, and we have one more version, that is an SS7 conformance scripts XX647. Right, designed for conformance test and functional test, where test objects can be accurately, reliably, and comfortably validated for compliancy with ITUT standard relating to the protocols Q point 761 to 764 and Q point 87884 protocol. I mean, we have to go through so many standards and specifications which are available relating to all these things. Okay, and apart from this, you can also have, there'll be some other emulators, right, to validate and check out many functionalities relating to an SS7, but this is one of the emulator which is available for you to go through it. Yeah, it is suitable for manufacturers, network operators, and service providers to address all stages of the development cycle. Regression testing through to type approval acceptance testing as well. Then lastly, we have the application gives the users the limited ability to edit SIP messages and control scenarios. Message sequences are generated through scripts. Messages are created using message templates. I mean, we have a certain templates, right? To generate, there will be the report, right? Accordingly, we can give the inputs so that we can extract them with the details from the available protocol analyzers as well. Yeah, the purchase of additional licenses are required for all the cases. I mean, we have some more here. That is an XX610, 620, FT0. Okay, right. As I mentioned, many more application level emulators are available currently in the market. Right. If at all you want anyone, you can just download it, but be careful while downloading as well. Right. So all these, emulators supported traffic, which includes transmission and detection of TDM digits, voice files, single tone, dual tone, speech, and there'll be fax services as well. That's what, the moment you look at your applications from this network or from this network, you can understand that what kind of services we could able to get it from using your SS7 protocol. The moment you get those services, you want to analyze something in terms of various parameters. Those parameters you have to be identified very clearly, and you can compare each service based on those parameters, and you can come to a conclusion that which one is good or efficient, or what is going to happen in terms of there'll be a transmission rate, or in terms of data loss, or in terms of there'll be the quality, or maybe in terms of latency, okay, bandwidth utilization, so on and so forth. All the things you can able to analyze it using these kinds of the emulators which are available during your SS7 protocol operations. I think this is what is you need to know about regarding SS7 emulator, or there'll be a protocol analyzer as well. I think these are all some of the slides which you are supposed to be go through it. I think I'm going to share these slides also today to study in detail, where you have there is an SS7 topic. You can go through SS7 protocol analyzer and emulator, and apart from that, where you have will be an ISDN services, you can also go through ISDN emulator and protocol analyzer PPTs in detail. So which covers all the details of unit 2, along with some tools which are available to work on SS7, and your ISDN services. Okay, do you have any questions? You can ask me, so that I can address it. Even if you have any other questions, also you can ask me other than this topic, so that I can address it. Okay. Hello. Yeah, do you have any questions now?
No, sir.
Yeah. Do you have any questions regarding the test, portions, and is it okay to all of you? Right.
Yes, sir.
Yeah, unit 1, unit 2. Okay, test 1 and quiz 1 questions are going to be framed based on that. Hello. Why it will continue in the next class regarding right now ATM networking. It's